Hello, welcome to the 5th tutorial on plotting. In this case, we will be looking at just basic plotting for functions of the form y equals f of x. In later tutorials, we will come back to different 2D plots and also to 3D plotting. But right now, starting just with basic y equals f of x graphs. But I want to look at many of the controls that you can add and the options to make your graph look the way you would like it to look. So first we'll open the section. All right, and I'm going to start down here. Plot x times sine of x. Please note there's a space in between x and sine to make that multiplication. And then x goes from -1 to 5. There are curly braces again, but that's going to give me my domain. Yep, -1 to 5 on the x-axis. Now, Mathematica chooses the range by default, and mostly for normal types of functions, it will show the entire graph. But if your function goes too high or too low, it will cut off part of it. But I can control a lot of that. So here's one option. And come back again, I start with plot. What am I plotting? Here's my domain. And then I can put a lot of different things in any order I want after those two initial pieces that must go in that command. So plot range arrow 5. Yep, and this shows a range going from -5 to +5. Just a shorthand way of writing that. On the other hand, since that may not always be appropriate, I can put in two values. I have my y min, in this case is -3, and y max is 8. And yes, I certainly don't need to go up to 8 here, but you can see how that works. Right, now, we can also look at plot styles. So here, I'm going to put in red. Well, blue is the default. That's very nice, but I'm going to change my graph to red. Okay. Here's a different type of plot style. I have a list of styles, in fact, dashed and thick. And it would give me some kind of nice graph here. Those values are by default just something that Mathematica, the Wolfram language, thinks would be nice, but I can control those. So here I'm putting in dashing with a 0.05 and thickness with 0.03. You'll see how the graph changes dramatically. I would suggest that you play around with those numbers a little bit, just to see what effect they have and how much things do change and what values you like. Okay, this can be particularly helpful for teachers if you're trying to make two graphs together and you're plotting them, but you want to distinguish one from the other and you're going to print it in just black ink. This can be very helpful just to use the dashing command. Okay. Other things that we can do here, aspect ratio. Well, we go back up here, and 1 unit on the y-axis is very different from 1 unit on the x-axis. If I choose automatic, it will in fact give me, it doesn't show this here because I don't have one shown, but the axes, 1 unit on each axis is the same size. Now, the other thing I did add here were ticks. Well, I've got trig in this graph, so I put in a list of 3 specific x values. Just pi over 2 pi and 3 pi over 2, they do show down here. And automatic, yep, I let Mathematica choose the y values that it wanted to put on the axes there. That was fine with me. I can here use commands like range that we talked about in the last tutorial. So I can put in a table of values as well, as opposed to just a simple list of values that I want to put in. Okay, another option here, plot label. And I do put this in quotation marks because it will be text. Now, please create one of your own graphs, make a bunch of changes, play with the numbers a little bit, with the aspect ratio. Make sure that you understand how some of these different options work because you will use them a lot when making graphs in Mathematica. All right, helping. A little tiny bit of help. We will come back to much more later, but right now I just want to start with the bare minimum. I'm going to start by typing PL because I know that's how my plot command starts. But there are a bunch of different, Sorry, let me try that again. There are a bunch of different commands that start with PL, and there are double arrows down here. I can show this. My list will go way off of your screen, but there are lots. Okay, right now I'll just come back to plain old plot, and we'll do that. Now, if I click again on the double arrows going down, I can see the syntax, but it also will allow me to paste it in. So if I can't remember exactly how that works, there's my function x from xmin to xmax. All right. Obviously, that can be very helpful in this case. What other options do I have, or how do I remember what options I have? Well, let's ask Mathematica. Options for the command plot, and this will obviously work for a lot of other commands as well. Whoa, lots of them. All right, these are all the defaults that it does behind the scenes. Aspect ratio, golden ratio rectangle. Axes we're going to put on by default. Axes label, none by default. All right, and you can go through this whole list in here. Some of these grid lines, none. I can change that, but I can guess what that does. Frame style, frame ticks. Some of these others down here may not be quite as obvious to you. Preserve image options. I'm not sure what that does. That's okay. You can play with it if you would like to. But my point here is that there are lots of other options that you can choose from and work with. But if you don't remember what it is or what something is you're looking for, you can ask Mathematica what the options that are available. Okay, now let's look at more graphs. I'm still back on 2D graphs, but I want to look at two functions. So plot, what am I plotting? Two functions, but within one list. So this is what I'm plotting, is these two functions, and then comma, and my domain here. Right, now, by default, Mathematica is nice enough to give you two colors in this case, but you may want to control more. All right, now plot style. Well, in this case, I have red goes with my first plot and blue goes with my second plot, or my second graph, that is. Now before, I had two options together. Well, if I only have one graph and I list two plot styles, then both of them are applied to one graph. But here I have the first one listed goes with the first graph, and the second plot style goes with the second graph. But what if I wanted to add more plot styles to each graph? I have a list of lists. Okay, so here are my two functions. My first function will be red and thick within curly braces, comma. My second function will be blue and dashed and thick within curly braces. Close off my list of plot style and then close off my function. All right, now let's look back at thickness and a few other things. And again, we can control these. You saw a little bit of that, but here I've got red and thickness for my first graph, and my second one is blue and dashing and thickness. Okay, I've done something new here too, because this dashing does not come out like that one. I have two numbers in here, which I did not have before. This is going to be for the length of the dashes, and that has to do with the spaces in between the dashes. So if I make that smaller, for example, and I go down to 1 there, it gets very small. That's too small. Don't want that. Or if I make this much bigger, I'll put a 6 in there, I get a much larger space in between the dashes. Okay, you can play with those numbers again a little bit, and this is fairly thin here, but that may be what you want. Now, colors. What colors? Well, I typed in red and blue. That was fine, but there are a lot more options. Okay, now let's go back up to palettes right now, and I'm going to come down here and look at color schemes. Okay, now this will block part of the screen right now, but I'll get rid of it shortly. We have gradients, and few other things that are going to be used more for 3D plots. What's interesting here is named within the system. Now, within system though, if you'd like, I can choose different options within that, but right now we'll stay here. And if I come down, here, I can see various colors. This is not, there we go. Okay, just I can type in nice normal names for a lot of different colors, light yellow and yellow, light green and green, various options in here. Okay, now, I can also use colors in different forms if I would like. I can use RGB, which is red, green, and blue, and I need numbers from 0 to 1 in each of those 3 spaces, and this should just give me a plain red. And if I come down here, another one that I find often easier to use is hue, with K being some number between 0 and 1. So at 0, again, I'll start out with red, and that follows the colors of the rainbow. So I can put in, for example, a 0.6. I'll get a nice blue out of that. Okay. Asymptotes. Now, Mathematica has figured out in recent versions how to not show vertical asymptotes. So I'll define my function g, and then I'll come back down here and graph g. And yes, with this rational function, there should be a couple vertical asymptotes in there, but they are not shown. Fine. Okay, but sometimes you want to show them. Now, this command's a little more complicated, but I think you might be able to see what's going on here. First of all, plotting g of x, here's my domain. Epilogue, stuff I'm adding later, okay, that's on top of my graph. Now, in the first set of curly braces here, so one piece I'm adding, a thick red dashed infinite line goes from -1, 0 to -1, 1. Well, -1, 0 seemed to be a good place to start, but the -1, 1, it's just going to be something vertical in here, and this infinite line will go to the edges of the window. And then I came down and did the same thing here with a line that starts at 2, 0, and I just put in 2, 1, but it doesn't have to be 2, 1. And again, for students, that can be very nice to see at times. The 1 was just purely arbitrary. If I'd put in 5 here, I would get exactly the same graph. It just connects the dots, and then we'll go to the edges of the window. All right, a couple more options that may or may not be useful at this point, but just so you know that they do exist. Mesh. Okay, first of all, let's look at Mesh All. This will show you a little bit more of what Mathematica is doing behind the scenes. Just plotting sine of x. So sine of x is relatively straight along here, and it's plotting these points that are not too close together. But as the graph becomes more curvy, then it plots a whole lot more points. Then it plots fewer points in here for a little ways where it's straighter, and then a lot more where it's curvy again. Mathematica chooses what points to plot to give you a graph that looks good. But I can control some of that, of course. Now, a couple other examples here. Mesh 12, that will give me 12 evenly spaced points along the domain. And I've made the points larger so you can see them in this case. Okay, so those are evenly spaced along the domain. What if I want them evenly spaced along the range? Well, then I have to do something else in here. Mesh functions, the number 2 is my second variable, so x is first and y is second, and the ampersand, that has to do with a pure function. I'm not going to touch that right now, but you can see what this does is this will show you evenly spaced points along the y-axis. Just a curiosity, perhaps, for teachers especially, but if you're trying to show exponential growth, that can be helpful. Region function. Now here, this command may seem a little bit odd right now, but that's okay. Region function, arrow. Here's my function, my variables are x and y, but I'm only going to graph this when absolute value of y is greater than 0.3. Okay, so there's my sine of x, but it left off the section between negative 0.3 and positive 0.3. And I can also do that and add a more complicated function in here. I can add all sorts of functions in here. Right now, just using fairly simple ones, I'm only graphing this when absolute value of y is between 0.3 and 0.8. So I can use inequalities, complex inequalities, whatever I would like. But it makes some graphs very interesting. Now, palettes one more time. Going to come back to our basic commands, and I'm in Classroom Assistant in this case, and I'm going to find the 2D button under Basic Commands, and so I find Plot. That's fine. I can also see More. Well, if I click on that, I can see plotting two functions. There's parametric, and again, we will come back to some of that. That's okay. I can bar chart, some other things, but also range and a few other options down here. Okay, let me start new cell, and I'm just going to hit plot right now, and it puts in the syntax for me. So something fairly simple, nothing too exciting right now, but that's okay. X squared, and if I tab over, I'm going to go x goes from -2 to 2. Okay, now I'm going to leave my cursor right there. But I'm going to come down to a couple other things in here. I can put in tick marks. I can do some other things. I'm going to put in style, plot style. And please note that put in comma, then plot style, and color or style. There are some options. I'm just going to come down here. I can come in and pick a color and just click on that color and it will put it in where I want it. But that automatic positioning that's listed in here, it knew where that needed to be. Mathematica knew where that needed to be within the graph. Okay, but I can do other options in here and frames and such things. If I want axes false, oops, I'm not in there right now. Yep, I am in there, sorry. Axes false, I can do that and it will still put the comma in and put my graph where it needs to be. I can put a frame on it, whatever I would like. Okay, various options in there. And exercise, oh yeah, a little more practice. So I'm giving you a couple functions here. Define both of those functions because that is, again, very good practice to get used to that notation. Cosine x and 1 minus x squared over 2. Plot both of them together, add some colors, thickness, dashing, whatever you would like. Put a frame around it, put a label on it, and call it approximations. And then make sure you clear your functions when you're done.